The Pythagorean Theorem. So the Pythagorean Theorem is fairly common, and we hear about it a lot, and it's simply a squared plus b squared equals c squared. And those letters represent the sides of a right triangle. So we've often heard of this, but today we're going to look at how we know it's true, and just a simple method of proving it. So to the left, I've drawn a shape where both of these are squares, one inside the other. The area of the big square we know has to be equal to the sum of the area of the shapes that make it up, namely the smaller square and the four triangles. So looking at the big square, we know its area is simple the side squared, and each side is simply a plus b. So our area there is equal to a plus b squared. And if we go ahead and do that math, that is equal to a squared plus 2ab plus b squared. Now, the area of the smaller center square we know must be c squared because it has all sides of c. And the area of our corner triangle is simply going to be 1/2 ab because triangle's area is equal to 1/2 times the lengths. So now let's kind of set those equal to each other, because we know that the area of the big square has to equal the area of the shapes that make it up. So therefore we know that c squared plus 4 times 1/2 ab equals a squared plus 2ab plus b squared. If we go ahead and expand out the left portion, in order to multiply that 4 and 1/2, we'll see that we get c squared plus 2ab equals our a squared plus 2ab plus b squared. Now we're simply going to subtract 2ab from each side. When we do this, we see we get c squared equals a squared plus b squared, which proves our Pythagorean theorem. This is a proof from about 2,000 years ago from the Chinese, so this has been known for a long time. So now let's use this in order to determine this problem, which is if a right triangle has a hypotenuse of 5 and a leg length of 3, what's the length of the other leg? So we have our Pythagorean theorem, a squared plus b squared equals c squared. And we know a and b are the legs, and c is our hypotenuse. We can see that from the pictures we have above in the proof and in our original drawing. So we know a is going to be one of the legs, so we'll say that is equal to our 3, and c is equal to 5. So now we just need to substitute 3 squared plus b squared equals 5 squared. And for our math, 9 plus b squared equals 25. b squared is equal to 16. And if we take the square root of both sides, we'll get b equals 4. So this is all about the Pythagorean theorem, how to use it, and how to prove why it works.